Welcome to the low temperature heat sources instruction video. As we are decarbonizing our energy system, we are insulating our buildings better, making them require less heat and at a lower temperature. But also require more cooling. To be most efficient with available energy and require less primary energy, we can harvest low-grade heat and cooling from local environmental sources or waste heat streams. After completing this video, you will be able to identify different types of low temperature heat sources, understand their typical temperature ranges and availability, and common applications. Let's start with aquathermal, an abundant source of thermal energy, especially in a water-rich country like the Netherlands. Aquathermal is a technology which utilizes thermal energy from water. This includes surface water, drinking and sewage water, each having their own pros and cons. Usually drinking water can be best used for heat extraction as a source for a heat pump. Also, sewage water is usually a good source for heating. Did you know that we quite literally flush a significant part of the heat generated in our buildings down the drain? Not only heated up water from showering and from the laundry, but also toilet water has commonly heated up to room temperature before we flush it. Close to where we use the water is the best place to recover heat from the sewer. Most efficient is the shower heat exchanger, simultaneously preheating your warm water with the water you just used seconds before. Such a shower heat exchanger will save around 50% of primary energy use for showering. Where drinking water and sewer water have a fairly constant temperature throughout the year, surface water temperature follows the seasonal temperature variations. The graph on the slide shows the monthly average temperature of the river Meuse, measured in Rotterdam. The Meuse is a reasonably sized river mainly carrying rainwater. Stagnant water bodies like lakes and ponds will have a larger variation in temperature level. As a result, the key challenge for utilizing thermal energy from surface water is seasonal storage. You can easily get cooling from cold water in winter, but you need it in summer, and opposite for heating. So you need to be able to store seasonally. To be able to assess and quantify the heat extraction from water is important to make an energy balance for the water body. The figure on the screen shows the key factors of the energy balance of a lake or pond. This includes air temperature, wind speed, solar radiation, evaporation, exchange with the underground. And for moving waters, also the outflow and inflow need to be considered, of course. Let's move on to the next low temperature heat source, which is waste heat. Whenever there's a cooling demand, there is waste heat. For example, from data center, air conditioning units, cold stores, supermarket, you name it. Usually in such systems, the waste heat is dumped into the outside air, making it rather difficult to actually utilize. For example, data centers have seen a significant increase in numbers and will continue to grow. Their energy use is predominant for cooling of processors. So data centers generate a constant supply of heat. So if you have the opportunity, for example, when a data center is being planned in your city, request for it to be built liquid cooled, so the heat produced by the processors can be utilized more easily and at a higher temperature level. Because processor power roughly equals heating power, they can provide a steady base load. And with heat output of temperatures over 50 degrees, make them suitable for many applications. Air conditioning systems and cold stores can act as heat sources as well. They exhibit a variable load profile with seasonal variations which do not match local heating demand, as cooling is needed when it's hot outside. The heat they produce is again usually available via the air, making it difficult to integrate them into various heating and energy recovering systems later. But like with data centers, when such systems are being designed, it is possible to get their heat more easily available via heat transfer fluid, although usually not at high temperatures as liquid-cooled data centers. Thirdly, we can also use outside air, using devices that allow heat exchange between a medium and the outside air, which we call dry or wet coolers. Their operations show both dynamic behavior as well as base load with seasonal variations. Like surface water, there is a clear seasonal mismatch with demand, so also here commonly seasonal storage and the heat pump are needed to be able to supply the heating and/or cooling. Lastly, we consider paved surfaces. Such systems use tubes buried in the pavement to exchange thermal energy, typically harvesting heat, but can also be capable of providing cooling. They exhibit a mix of base load and seasonal variation. Flexibility is low and the available temperature range is suited for low temperature heating with a heat pump or preheating applications. Such systems are only cost effective when the pavement is being built or refurbished. Putting the heat exchangers in place for harvesting heat only is not cost effective. Now, let's go to the applications. Aquathermal energy is mostly used for heating in conjunction with seasonal storage and heat pump. For example, heat from a sewer for a swimming pool or the shower heat exchanger I discussed before, now shown on the screen. Or heat from the River Meuse for a high-rise building in Rotterdam, combined with seasonal storage in the underground. Waste heat from industrial or urban processes can be fed into district heating networks, for example, the industry in the Amsterdam and Rotterdam harbors, which is distributed in the region. Or in Amsterdam, where they use data center heat via seasonal storage in the underground for the university buildings there. Outside air is commonly used as a source for heat pumps, either directly or via seasonal storage. While paved surface systems can harvest heat to provide cooling, in the latter case they could also be used in conjunction for de-icing roads in winter. To summarize our learnings, we have learned that various sources of low temperature heat exist, various types of aquathermal, waste heat from a variety of sources, outside air and paved surfaces. Furthermore, we discussed that these sources are commonly abundantly available and mostly follow a seasonal pattern in availability and temperature level. We also showcased various examples of applications. Throughout these applications, we see that when utilizing low temperature heat sources, often either a heat pump, seasonal storage, or both are needed. That is why we cover these in the next lesson.